Hello guys, in this video we continue talking about time series analysis and forecasting, the part 2. So we're gonna take a look at different steps in terms of decomposing the time series data into the seasonal component and then the trend component. So forecasting with the trend and seasonal component. Step number 1, we calculate the center moving average. So basically, we just average those numbers from different periods and get a center moving average. And the second step, we center the center moving average at the proper period. So I'm going to give you an example in a second to show you how to put in the proper period. And then step 3, determine the seasonal irregular factors, which is ST times IT, right? ST represents seasonal component. And IT represents irregular component. And then step 4, we determine the average seasonal factors. So basically figure out what is the average seasonal factor, ST, right? Average ST. And then we can scale the seasonal factors. And step 6, determine the deseasonalized data by dividing the original data, YT, by ST to get a deseasonalized data. And from there, we determine the trend line based on the time t and also the YT over ST. So we perform a linear regression on that and then get a trend line for this time series data. And step 8, determine the deseasonalized prediction, meaning once you have that, you're going to multiply back TT by the seasonal factors, right? And then eventually you multiply back to the take into account the seasonality. Okay. So that's basically the entire process of the time series analysis. And let's take a look at an example. We're going to go through each one of these steps. Okay, so let's see. So we get a terrace tie shop, business. A terrace tie shop could be divided into 3 seasons. First one is Christmas, usually between November and December. Father's Day, late May to mid-June. And the third one is all the times. Okay. So average weekly sales during each of the 3 seasons for the first past 4 years are given in the next slide. As you can see, this is year 1, season 1, season 2, season 3. Season 1 is a Christmas. Season 2 is Father's Day. Season 3 is all the times. So as you can see, usually either the Christmas or the Father's Day will reach the high sales volume, and then the season 3 is kind of like a slow season. So we're going to determine a forecast for the average weekly sales in year 5. You don't know year 5, right? So we're going to come up with the numbers for year 5. So that's the most important thing about the forecasting. So basically we are predict future period, the sales for future period, which is pretty amazing. Okay, so let's look at the detailed procedures. So start with the center moving average. So we're gonna get a first center moving average by adding the first 3 numbers. So as you can see here, so the first 3 numbers, so adding those 3 numbers and divide by 3. And because we select 3 seasons, so the center here will be in season 2. That's why we put this center moving average at year 1, season 2, right? So that's how that goes. If you go down to next block, which is year 1, season 2, year 1 season 3 and then year 2 season 1. Then the middle is located at year 1 season 3. So which is that? So that's why. So this number is achieved by adding 2012 by 985, adding 1995. Okay, divide that by 3. So we get 1664, and we put it. We align that with the year 1 season 3 actual sales, right? So this is what we call the first couple steps. Okay, so calculate the center moving average. The second step is put center moving average at a proper period, right? So that's a very, very important thing. So align them properly. That's so we get all the center moving averages. The next step is get ST times IT, right? So ST times IT equal to YT, which is actual sales number, dividing by the moving average for that corresponding period. So we get this STITs. So if you look at it, we're just dividing the sales number by moving average. So you get this seasonal and then irregular component. The product those two. Okay. So the first one, dividing 2012 by 1617.67, we get this number 1.244. And dividing 985 by 1664, we get 0.592. And same thing here, get all of these. And so basically we separate seasonal component and irregular component from the original sales number. Okay, so we get all of this seasonal and irregular component. Now next step, for all of season 1, so you're gonna average all those season 1 numbers. So if you look at it, so this is season 1 numbers. Okay, which is this. Okay. Season 1 numbers. 1.196, which is the next one. We'll take that number. Season 1 numbers. Take that. So we're gonna average those 3 numbers. That's how we get this season 1 seasonal component for season 1. Okay, so you add those 3 numbers divided by 3, you get a 1.180. For season 2, we do the similar thing, right? So go back here, we take all the season 2. This is season 2. That is season 2. So we take this number, season 2. This is season 2. We take this number, season 2, and also season 2 right here. So there are 4 numbers here. We're going to average those 4 numbers to get the seasonal component for season 2. So adding those 4 numbers, divided by 4, we end up with 1.238. Season 3, very similar. So we get season 3 here. Okay, this is season 3 and season 3. Okay, so we take those 3 numbers, average those 3 numbers. So add those 3, divide by 3, we get 0.587. So this is like the raw seasonal component. If you add up those 3 numbers, it's 3.005. Now we're going to scale back because it doesn't add up to 3. So we need to scale back by averaging this. So 3.005 by 3, we get approximately 1.02. So we're going to scale back each one of this seasonal component by dividing each one of this number, right? Season 1 component by the scaling factor. Okay. 1.002, we get 1.178. Seasonal component for season 2 divided by the scaling factor, which is 1.002, we get 1.236, and then also 0.587 by 1.002, we get a 0.586. If you add in those 3 numbers, now it scale back to 3. Okay, so meaning on average, each one is worth 100. Each one is worth 1, which is 100%. So this is called scale the seasonal factors. Now, once we scale the seasonal factors, we get this the new seasonal component, which is scaled seasonal component. Now, next thing is dividing the YT by ST to get the deseasonalized data. Once you divide that, we get rid of the seasonal component. Right? Get rid of seasonal component. The original data, original time series data. Now, once you do that, we get this deseasonalized data, right? Sales number. So dividing this by 1.178, 1856 by 1.178, we get this. Okay. Dividing 2012 by 1.236, we get 1628. Dividing 985 by 0.586, we get 1681. Now, if you look at this, that's a trend. That's upward trend, right? As the time increases. Okay, so now we're gonna code the time t, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 years or 12 different seasons, and we code it from time t, right? Time t from 1 to 12, and then this is like a deseasonalized sales number. We're gonna run a simple linear regression based on these two, time t and then the deseasonalized sales number. Then we get this regression line using the least square methods. So T of t, which is trend component, trend prediction using the regression model. So it's 1580.11 plus 33.96 t, right? So B0 here is 1580.11, B1 is 33.96. All right, and based on these two, right, we're doing the time t regression analysis on time t and also the deseasonalized sales number. We get this regression model, and we can use regression model to make prediction. So for year 5, season 1, it should be coded as 13, right? That's why you see 13 here. And year 5, season 2, that'll be 14. Coded as 14. Year 5, season 3, that will be coded as 15. Okay, that's why I see 15 here. And we just plug into the regression model, which is T of t equal to 1580.11 plus 33.96 times t, right? And the t is 13. Replace t with 13, we get 2022. Replace t with 14, we get 2056. Replacing t with the 15, we get 2090. Again, it's an upward trend, right? So this is basically, so we get a forecast based on the trend element. Now we take into seasonality, right? Meaning you multiply each of these seasonalized predictions, which is based on a regression model, by the seasonal factor. So multiply this 2022 by season 1 factor is 1.178, you get 2382, and multiply 2056 by 1.236, which is a seasonal factor, deseasonalized scaled seasonal factor by trend prediction, so we get this forecast for year 5 season 2, and also year 5 season 3. So for year 5, and multiply 2090 by the seasonal factor, scale seasonal factor, so it's 1225. And so basically we get the year 5 sales number, season 1, season 2, season 3. So this is the complete analysis, right, on the time series data. On next video, I'm going to go over the Excel operations step by step, and you'll be able to master the skills based on from Excel. And basically, there are some other methods we can utilize to do the forecasting. One of them is called qualitative approaches. So if you are interested in that, there are different approaches developed by statisticians. First one is Delphi approach. Second one is scenario writings, and the third one is subjective or interactive approaches. So if you're interested in that, you can look at this and learn from there. Okay, so that's end of the video.